Hey guys, sorry I can't be there today to teach you the lesson myself and answer all your questions, but I'm hoping that this video will help you guys out with the lesson. Alright, so this is my first Algebra 2 video ever that I'm making, so I hope it's helpful and I hope you guys can see everything just fine. Alright, so your notes today have two parts. The first part is deriving quadratic functions. Deriving meaning obtaining or how we get quadratic functions. So we're going to see how we are able to do that. And the second part is more applying quadratic functions to real world situations. Alright, so let's get started on part one. Alright, so consider the following graph. Okay, how many lines can be drawn through points A, 2, 3, and B, negative 3, 0? So if I were to come over here and plot points 2 up 3, and then negative 3, 0, okay, the question is how many lines can be drawn through these 2 points? Right, and the answer is C, or one line can be drawn through 2 points. Okay, so a minimum of 2 points are required to draw a unique line. Okay, how many parabolas can be drawn through those 2 points? Okay, so maybe take a second right now to think about how many parabolas could be drawn through these 2 points. All right, guys, so I hope you thought about that. Well, really, infinitely many points could be drawn, right? I could have a parabola going here, right? I could even maybe flip it over. Maybe I just moved my parabola more shallow and made it wider. Okay, I could just keep drawing different types of parabolas through those 2 points. Okay. So infinitely points or parabolas could be drawn through 2 points. Okay. So now consider the following graph. How many parabolas can be drawn through points 3, 5, 5, 3, and 7, 5? So let's go ahead and graph those or plot those. 3, 5, and then it's 5 up 3, and then 7 over 5. 7 up 5. So how many parabolas could we draw through those 3 points? Right, well, the only way to draw any type of parabola through 3 points is just one way. Right, so really, in conclusion, a minimum of 3 points are required to draw a parabola. All right, what's the point of that? Why did we even go through that? Well, the whole point is that that's how we derive quadratic functions. We need at least 3 points in order to figure out what our quadratic function is going to look like. Okay, so let's come down here. All right, so we can use algebra to write the equation of a quadratic function represented by a parabola in standard form. So remember, guys, standard form is y equals ax squared plus bx plus c. All right, so we can create a system of equations using the 3 given points. So you're going to write one equation from each point. Here are our 3 points for example 1. And we want to use a system of equations to derive the equation of the quadratic function that passes through these points. Okay, so we're going to write one equation from each point. Okay, so whatever our y point is, we're going to plug that into here. Whatever our x value is, we're going to substitute that in for x. Okay, so I'm going to write my system of equations right here. For my first point, it's 2, 3. So since I have 3 for y, I'm going to say, oops, not y, 3 is equal to a And now where there's an x, I'm going to substitute that 2 in. So 2 squared plus 2 times b plus c. Okay, then I have, my next point is 313. So where there's a y, I'm going to substitute 13 in for that. And then I have a 3 squared plus 3b plus c. And now my last point is 429. So where there's a 29, I'm going to substitute that in for y. Okay, then I have a. Now I'm going to substitute 4 in for my x. Right, there's my 3 systems. And I'm just going to clean these up a little bit. So my first equation, I have 3 equals 2 squared is 4. So I have 4a plus 2b plus c. All right. Then I'm going to have 13 equals 3 squared is 9a plus 3b plus c. And then on the bottom, I have 29 equals 16a, because 4 squared is 16, plus 4b plus c. All right, now if at any point, guys, I'm going too fast for you, just pause the video, rewind it, rewatch what I just did, whatever you got to do. If I'm going too slow for you or you're like, I got this, then go ahead and skip forward. All right, so now that I have my 3 system of equations, okay, I'm going to use either elimination or substitution to figure out what my variables are going to be. The variables we're looking for are a, b, and c. Okay, remember back to that unit where we did solving a system of 3 equations? I hope you do. I wasn't kidding when I said nothing in Algebra 2 just goes away. Okay, so you can either do substitution or Gaussian elimination. I am going to do Gaussian elimination, okay? So first things first, we need to eliminate one variable. Okay, it doesn't matter which one, A, B, or C, and we can do that using any 2 equations. Doesn't matter which 2 we pick. Okay, now, even though it doesn't matter which variable we choose to eliminate first, okay, I recommend always eliminating C first. We see how it's 1C in every equation. Well, that's going to make it really easy to just multiply one of our equations by -1, so we can eliminate that C. So just a little tip, I think it's easiest to eliminate C first. Oops, that's not how you spell eliminate. All right. Easiest to eliminate C first. Okay, so now I'm going to do, this is kind of like my step 1. My step 2, pick any 2 equations. I'm just going to pick my first 2. 3 equals 4a plus 2b plus c, and 13 equals 9a plus 3b plus c. Okay, so I have my 2 equations. Now in order to eliminate c, I just need to multiply one of these by -1. So I'll just do my bottom one. It doesn't matter which one you chose. Okay, so my top stays the same. 3 equals 4a plus 2b plus c. My bottom, I'm multiplying everything by -1. So now I have -13 equals -9a minus 3b minus c. And I'm going to add these 2 together. Okay, so 3 plus -13 is -10 equals 4 plus -9a is -5a. 2b plus -3b is -b, plus c minus c, eliminate just like we wanted. Okay, now go ahead and box this, star it. Okay, we're gonna come back to that later. All right, step 3. Okay, now there are 2 rules for this next step, okay? One rule is we have to use the equation we have not already used. Okay, so these are the same rules that applied when we did solving systems of 3 equations a couple units ago. So we haven't used the third equation yet, so I'm going to rewrite that here. 29 equals 16a plus 4b plus c. Okay, and then it doesn't matter which other equation you choose to eliminate c with. I'm just going to do the top one. So 3 equals 4a plus 2b plus c. Okay, you could have chose the middle one. Okay, so again, I need to, my second rule is that I have to eliminate the same variable I chose to eliminate the first time around. Since I eliminated c the first time around, I need to eliminate c again. So in order to do that, one of them needs to be positive and one needs to be negative. So I'm going to multiply my bottom by -1. Okay, so my top equation just stays the same. 29 equals 16a plus 4b plus c. And then my bottom one, everything is being multiplied by -1. So I have -3 equals -4a minus 2b minus c. And we're going to add these up. Okay, so 29 plus -3 is 26 equals 16a plus -4a is a 12a. And then 4b plus -2b is plus 2b. And then plus c minus c, those will eliminate just like we wanted. All right, so box that, star it. All right, we're going to use that next. Okay, so now our next step, okay, we're going to use these 2 equations I've boxed here in red to help us eliminate our either A or B. So step 4. So I'm going to rewrite my boxed equations in red. -10 equals -5a minus b. And then I have 26 equals 12a plus 2b. All right. Now from here, it doesn't matter if you choose to eliminate A or B first. But does one of them look easier to eliminate than the other? Sure does. B looks like it's probably easier to eliminate. We just have to multiply the top one by 2 so that we can have a -2b and a positive 2b. Okay, so I'm going to multiply this by a 2. So when I do that, everything, I get -20 equals -10a minus 2b, and then the bottom stays the same. 26 equals 12 plus 2b. All right, so now we can eliminate b. -20 plus 26 is 6 equals -10a, plus 12a equals 2a. -2b plus 2b, those will eliminate like we did. Okay, so can we find what a is? We sure can. When we divide by 2 on both sides, okay, we get a is equal to 3. Awesome. So now it's just kind of the easy stuff from here. Plug what you got for A into one of our boxed red equations so that we can find B. Okay, so I'll just do it to this one right here. It doesn't matter which one you choose. So I have -10 equals -5, and I'm going to substitute 3 in for A, minus B. Okay, so I have -10 equals -5 times 3, -15 minus B. Okay, so when I add 15 to both sides, -10 plus 15 is 5 equals -B. So to make B positive, I get that positive B equals then -5. Awesome. Okay, now for my very last step, I just plug in my A and B into one of my 3 original equations. Doesn't matter which one I choose. So I'm just going to choose the first one. I have 3 equals 4A. Well, for A, I'm going to substitute 3. And plus 2B, well, B, I'm going to substitute -5. And then plus C. So 3 equals 4 times 3 is 12, plus 2 times negative 5 is negative 10 plus c. So 3 is equal to 12 minus 10 is 2 plus c. When I subtract 2 on both sides, 1 equals c. Awesome. So I have now found what my a, b, and c are. So can I write my quadratic equation in standard form? I sure can. So I would get that here I have y equals 3x squared minus 5x plus 1. You just put your a, b, and c into their appropriate spots. All right, guys, so that's how to derive quadratic functions. So go ahead and turn your page of notes. Okay, so we can also write the equation of a quadratic in vertex form if you are given the vertex of the graph and another point on the curve. Okay, so the vertex, so here, vertex form, okay, I'm going to write it right here. Y equals a times b times x minus c squared plus d. Okay, so does this look familiar to you guys? I hope it does. This is actually that transformation equation that we just worked with for transformations of quadratic functions. Okay, so remember when we moved C, that moved our vertex around left and right. When we moved D, that moved our vertex up and down. Okay, so our new vertex was landed at CD. Remember how we had to find the vertex of our graph for those transformation equations? So CD is the vertex. Okay, a point on the curve, that would just represent XY. Okay, so now for our purposes though, for what we're going to do, we are going to assume the horizontal dilation, meaning B, is 1. Okay, so assume B equals 1 for our purposes. So then our new quadratic function from there, our vertex form, well, we're going to get rid of that b since it's just 1. So we're left with a times x minus c squared plus d. Okay, so that's the one we're going to work with. All right, guys. So let's look at example 2. Okay, so we're given negative 3, 4 is the vertex, okay? So this negative 3, 4 is our CD. And then negative 4, 1 is a point on the parabola. Okay, so that will be just xy, our x and y coordinate. So write the quadratic equation in vertex form. So all we have to do is plug in our values into their, or substitute them into their appropriate spots here. So I have y equals a. Do I know what a is? I sure don't. So, oops, sorry, it's not y equals. Y is equal to 1. Okay, we were given that. So we have 1 is equal to, okay, we were not given a, so we're going to solve for a. Okay, multiply that by x minus c. Okay, our x in this case, they told us is negative 4, minus c. Our c in this case, they told us is negative 3. Okay, so negative or minus negative becomes positive 3 or plus 3. All right, squared plus d. And d in this case, they told us is 4. Okay, so I'm just going to clean that up a bit. So I have 1 is equal to a times negative 4 plus 3 gives me negative 1 squared plus 4. So I get 1 is equal to, well, negative 1 squared is just 1. So I just get a plus 4 So when I subtract 4 on both sides, 1 minus 4 is -3. So my A is equal to -3. So now that I know what A is, now I can write my equation in vertex form for my parabola. And so we just want to leave y and x as y and x. We don't want to actually write our specific point in our equation because we want our resulting quadratic equation to fit for any point, not just one. Okay, so when I rewrite my equation, I have y equals A, which we found was -3, and then I have x minus c, which we found would be x plus 3, since c was -3, squared plus d, which was 4. And that's that. So we just went to vertex form in the same way that when we completed this square on our last quiz, how we went to vertex form on that. We went to the same form in both situations. All right, so now go on to the next example. So you can also transform a quadratic function from vertex form to standard form. Okay, so we're going to use this equation from that example to go to standard form. Okay, so in order to get it looking like y equals ax squared plus bx plus c, all we got to do is just multiply, okay, FOIL this x plus 3 squared out. So I'm going to be left with y equals -3 times x plus 3 times x plus 3 plus 4, okay, because x plus 3 times x plus 3 is x plus 3 squared. So I get y equals -3, x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9 plus 4. All right, so now just clean it up. Y equals, okay, I'm going to go ahead and combine my 3x's. So I get 3x plus 3x is 6x. Okay, and now I'm going to distribute my -3 on the inside. So y equals -3x squared minus 18x minus 27, whoops, sorry guys, minus 27. I just distributed my 3 to each of my terms, and then I have plus 4 on the outside. So now combining -3x squared minus 18x, -27 plus 4 is -23. All right, so that's it. Okay. Go on to the next page of notes. All right, so part 2, quadratic applications. Okay, so we're going to see how using what we just learned can help us solve some real world stuff. Okay, so first of all, finding max and min, that's one common use of quadratic equations in real world applications, okay? Think about it. So our maximum and minimum, where does that occur on our quadratic graphs? Well, it occurs at the highest point or the lowest point. What's another name for the highest point of our graph or the lowest point? All right, we just took a test over this. That's going to happen at the vertex, okay? That highest or lowest point. Okay, so we can find the vertex of a quadratic function using 2 methods. First of all, if it's in vertex form, then that's pretty simple and straightforward from there. It's just going to be located at your CD. Okay, so just the way we found vertex on our last test. Okay, however, if the parabola is in standard form, so if it's written like this, okay, it's going to be really, it might be a little tricky to find our vertex. We'd have to start factoring and get it in vertex form, or maybe even complete the square to get it in vertex form. Okay, so I'm assuming you guys don't want to have to go through all that. No? Well, lucky you, because if that's the case, then we have a little trick. So the x-coordinate of the vertex can be found at -b over 2a. Okay, so that's our little trick to finding vertex if it's in standard form. Okay, All right, so the y-coordinate of the vertex is then what? All right, well, if I'm trying to find max or min, right, I find what my x-coordinate is at that maximum or minimum point. Well, how would I find the y? Well, all I need to do, just plug in x and you'll get what your y is equal to. Okay, so our y is just equal to whatever we get when we plug negative b over 2a in. All right, so let's see how this works by trying a motion problem, okay? All right, so the equation given right here is commonly used to model an object that is launched or thrown. The variable h represents the height in feet, okay, and t represents time in seconds. So h and t are two variables. The other two values are usually given by h sub o, the initial feet, okay, initial height in feet, and v sub o, which is the initial velocity. Okay, so consider a ball launched upward at 48 feet per second from a platform that is 64 feet high. All right, so first of all, the ball is launched upward at 48 feet per second. Okay, so which variable do we think that belongs to? Well, that represents velocity since it's feet per second. So this is going to be our v sub o. And then if it's launched from a platform that is 64 feet high, all right, then 64 is our initial height, so that's h sub o. So I'm going to rewrite this equation and substitute in my two values for v and h sub o. So I get h is equal to negative 16t squared plus, now I'm going to substitute in 48 for v sub o. And then I'm going to substitute in 64 for my h sub o. Okay, so this is the equation I'm going to be working off of. All right, so part A. It says, find the time it takes the ball to reach its maximum height. So if we want the maximum height of the ball, well, maximum and minimums, those occur at our vertex. So if we want the time it takes, okay, then we're going to be solving for our x value, x coordinate, but in this case it's t, okay, instead of x. Well, our little trick that we gave you guys in order to find that, whatever your x, or in this case t, is at your maximum or minimum is, it's equal to negative b over 2a. So we're going to find what negative b over 2a is equal to. Our b in this case is 48. So we have negative 48 over 2 times a. Our a in this case is negative 16. So that is equal to 48 over 32 when I simplify. And then now, because we have a real world problem here, it is okay to use decimals. 48 divided by 32, we would be left with 1.5 seconds. Okay, so our ball reaches its maximum height at 1.5 seconds. Moving on to part B. Find the maximum height of the ball. Okay, so we know the time where our maximum height occurs. So can we figure out our height where the maximum, where the max occurs? Yeah, we can. All we have to do is plug in 1.5 in for our time, t. So h is equal to negative 16t squared. So I'm going to substitute 1.5 in for t, plus 48t, substitute 1.5 in for that, plus 64. Okay, so I encourage you now to just plug this in your calculator. Try to solve it for yourself. You can pause the video. Okay, so if you plug this into your calculator, you get that h is equal to 100 feet. All right, so our maximum occurs at 1.5 seconds and reaches a total of 100 feet. Okay, so C, find the time the ball will spend in the air. Okay, so I'm gonna draw a picture for you guys. It wants the total time that the ball is gonna be in the air. So the ball started here, right? It started at 64 feet high. Okay, and so the ball was launched, right? It reaches its maximum of 100 feet. Oops, I'm sorry. 100 feet right here. That's 1.5 seconds. Okay, and then it's gonna start falling. Okay, and it hits the ground. Okay, so the total time that the ball is in the air, okay, is gonna be from our starting point here until it hits the ground. Okay, so when the ball hits the ground, we wanna know what this t is gonna be, okay? That's our mystery value. Well, where is t happening at? T is occurring whenever our ball hits the ground. What's our height when ball hits the ground? It's at 0. Okay, so to find what t is at this point, we're gonna plug in 0 for our height. Okay, and that will give us the total time that the ball was in the air. So 0 is equal to negative 16t squared plus 48t plus 64. Okay, and if you guys weren't quite sure why we're plugging in 0 to figure out the total time the ball will spin in the air, okay, one last time, we're doing 0 in for h because the ball, when it hits, we don't know what t is, okay, right? But the ball will hit a height of 0 once it is finished flying in the air. Okay, so if we want to know that point right there, okay, that t value, that's why we want to use a height of 0, okay? All right, so does this look familiar, okay? Can we solve for t from here? Well, sure, it's equal to 0, so we're gonna solve for t in the same way we've been solving for x these last few days for our quadratic equations. We can either use quadratic formula, we can complete the square, or we can factor, whatever you're most comfortable with. Okay, I'm gonna factor. Personally, I know that all of them have a greatest common factor of negative 16. So I'm going to pull that out in front. So I'm left with t squared. 48t divided by negative 16 leaves me with negative 3t. 64 divided by negative 16 leaves me with negative 4. Okay, so now I'm going to factor this out. Okay, so I have 0 equals negative 16, two numbers that add to negative 3, but multiply to negative 4. Okay, I encourage you to try to maybe pause the video, think about this on your own. Right, negative 4 and 1 will multiply to negative 4, but add to negative 3. So since it's negative 4 and 1, we get t minus 4 and t plus 1. And so from here, we can definitely solve for t. All right, remember, if it's just a number out in front, well, negative 16 will never equal 0, so that's not going to be one of our values for t, okay? That's not possible. So we're just going to set t minus 4 equal to 0 and t plus 1 equal to 0. So when we do that, we get t equals 4 and t equals negative 1. Now let me ask you guys, okay, does it make sense to have negative time? Okay, some people in my other class were like, yeah, we have time machines. Okay, well, sure, fine. But for our purposes, we're assuming no time machines, okay? No, it doesn't make sense to say it happened at negative 1 seconds. So that's not gonna be our answer. It's just gonna be t equals 4. Okay, there might be times, guys, where we could get two possible answers for time if one was, if they were both positive. For instance, if maybe a ball bounced, okay, then we would be able to figure out the 2 times where the ball bounced. For this purpose here, Okay, I had a question. Well, what if we had gotten two positive values for here? Well, we're working with a real world situation, so we would not be ending up with two positive values for t here. So just the one value for t is our answer. T equals 4 seconds. And yes, guys, you do actually have to write out 4 seconds, okay? Remember, real world situations, we need labels. Okay, last part D, find the time it takes for the ball to reach a height of 36 feet. Okay, so if we want to know the height at 36, just plug in 36 for that, for H. So we get 36 equals negative 16 t squared plus V sub OT plus HO. Oh, what am I doing? Why did I write that? I'm sorry, guys. I mean 36 equals negative 16 t squared plus 48t plus 64. Yeah, it's like super early in the morning right now, so sorry if I sound a little tired. All right, so can we find t from here? We sure can, okay? Just set this equal to 0, okay? So move our 36 over. 0 equals negative 16 t squared plus 48t, and then 64 minus 36 gives us plus 28. Okay, so if we factor this out, 0 equals, this is why it's not good to do math in pen. I just wanted it to be dark enough for you guys. Okay, if you pull out a negative 4, that's our greatest common factor between our three numbers. Okay, and then I'm going to kind of do this one a little bit quicker. So then whatever you're left with on the inside will factor out to 2t minus 7 and 2t plus 1. Oops, sorry, there you go, guys. 2t plus 1. Okay, I encourage you guys, pause the video, see, factor for yourself and see how I got from here to here. Okay, we should be pretty fairly good at factoring by now. We just took a test over it. But also, guys, remember, if you had chosen to complete the square or use the quadratic formula, that's fine too, okay? I just did my factoring. And I forgot my t here. Okay, so pause the video, see if you can get the same answer that I got. If you can't, ask a group mate or a classmate to see if they can help you out. Okay, so then when we try to find our t values, we set both of what's inside of our parentheses equal to 0. Okay, and then when we do that, we get that our, so 2t minus 7 equals 0. So 2t equals 7. So t is equal to 7 halves. Then we have 2t plus 1 equals 0. So 2t equals negative 1. Divide by 2, we get negative 1/2. Well, again, it doesn't make sense to say we have negative time. So 7 halves is going to be our answer. So 7 halves, 7/2 seconds. Okay, guys. So go ahead and flip the page. There are 2 more real world examples. Okay, if you decide you want to get started on your homework right now, okay, that's fine. At any point you feel comfortable, you get started on your homework. I'm just going to keep working these examples out for you guys, okay? So for our first example, okay, the profit for a company produces custom gift baskets. It can be modeled by this equation right here. X is the number of gift baskets, okay? P is profits. So that's going to be profit. All right, so A, how many gift baskets does the company have to sell to break even? No profit, but no loss. So if they break even, they don't have negative or positive profit. So our profit's equal to 0. Okay, so 0 is equal to negative 2x squared plus 20x plus 2400. So can we solve for x, the number of gift baskets? We sure can, okay? So I'm going to take out a negative 2. That's my greatest common factor here. Remember, use factoring, quadratic formula, complete the square, whatever you're most comfortable with. I'm going to factor. So I'm left with x squared minus 10x minus 1200. Okay, two numbers that multiply to 1200 and add to negative 10. Okay, well, so side note here, so note that negative 40 plus 30 equals negative 10. Negative 40 times 30 equals negative 1200. So negative 40 and 30 are my two numbers. So I have negative 2 times x minus 40 and x plus 30. So once again, negative 2 can never be equal to 0, so I'm not going to worry about that out in front. I just need to set my x minus 40 equal to 0 and my x plus 30 equal to 0. So I get that my x is equal to a positive 40 and my x is equal to a negative 30. Okay, does it make sense to have negative 30 baskets? No. So my my baskets to break even that I would need to produce to break even is 40 baskets. Okay. So now part B, how many baskets should they sell to maximize profit? And what is the maximum profit? Okay, so we're trying to find out the number of baskets and the profit at our maximum here. So maximum, okay, where does that occur? That occurs at our vertex. What little trick did we give you guys to find your x value for your vertex? Well, maybe look at your last page of notes, but it's negative b over 2a. Okay, so I'm going to plug in negative b. My b in this case is my 20, so I have negative 20 over 2a. My a is negative 2. So negative 20 divided by negative 4 equals 5. Okay, so 5 baskets is the maximum they should sell, or the number of baskets they should sell to maximize profits. Okay, and then for how much that costs, all we have to do is plug 5 in for our x, okay, to get profit. So we get negative 2. We're going to substitute 5 in now for every x, okay? So negative 2 times 5 squared plus 20 times 5 plus 24. Okay, solve that and you get p is equal to $2,450. Remember, you do need to have a money sign. Okay, so last example. Bob made a quilt that is 4 feet by 5 feet. I'm just going to draw that. I like drawing pictures. I recommend you guys do the same thing. Okay, so this is 5 feet. And this would be the 4 feet. 4 feet by 5 feet. He has 10 square feet of fabric to add to a border to the quilt. How wide should he make the border in order to use all the fabric? So the border must be the same width on all 4 sides. So I'm just going to draw my border around. It has to have the same width on all sides. So if this width, we don't know what it is, so we'll just call it x. Okay, so it's x amount wide here, it's x amount, okay, here going up and down. All right, so, okay, we want to find how wide he should make the border. So we're trying to figure out what is this x value here. How can we even figure that out? Okay, well, let's think about some things we know. We know that our quilt on the inside is 4 feet by 5 feet, okay? So could we figure out a certain value given those two numbers? Well, sure, we could figure out area if we multiply 5 times 4. Okay, so why don't we go ahead and do that? Okay, so I'm going to find the area of my quilt. Oops, there's an L in there. Okay, the area of my quilt is just this 4 times 5. So that's 20 feet. Okay. I do also know the area of my border. They told us it was 10 square feet. So the area of my border is, oops, and I should have a square there, 10 feet squared. Okay. So if I could find my total area of everything and so subtract my area of my quilt, okay, then I should get the area of my border. Okay, so total area. Okay, well, total area we know is 20 feet plus 10 feet, right? So that's 30 feet squared. So, okay, we need to be able to represent total area using our X values. Can we do that? For sure. Okay, so let's look at our picture. So on this side, okay, we're trying to figure out our total area. On this side, okay, I know in here is 4 feet, okay, right, so I'm trying to see how long this side is. If this is 4 feet, right, and then this part right here is X, this part right here is X, then I'm going to have X plus 4 plus X for this side. Okay, if that was confusing, maybe rewatch that again. Okay, so now on, for my length, I know this is 5 feet, okay, my quilt on the inside, and then this side here, this width of the border is X, and this width is X. So this total side should be X plus 5 plus X, okay. So if my total area is equal to 30 feet, well then 30 is equal to these two numbers multiplied together, right? These two numbers should give me the total, when I multiply them, should give me the total area of everything. So I'm going to say 4 plus X times 5 plus X are equal to 30. Okay, and now just solve and simplify. So 4 plus X is plus 2X. 5 plus X is plus 2X. Okay, now distribute. 4 times 5 is 20. 4 times 2X is 8X. 2X times 5 is 10X. And then 2X times 2X is 4X squared. Okay, so now we can combine like terms and get it equal to 0 so that we can figure out what X is. So we have 4X squared, 8X plus 10X is 18X. When I subtract 30 over here to make this equal to 0, right? I want that equal to 0. 20 minus 30 is negative 10. Okay, so now you can use any method you prefer to figure out X. Okay, I'm going to factor. So I'm going to take out a 2 out in front. So I get that I have 2. I'm just going to come over here, guys, to do that. So I'm taking a 2 out from here. So I get that I'm left with 2x squared plus 9x minus 5 equals 0. Okay, so now I want two numbers that add to 9 and multiply to 2 times negative 5, which is negative 10. Okay, which two numbers are that? Well, 10 and negative 1 should give me those. 10 times negative 1 is negative 10. 10 minus 1 is 9. Okay, so from here I'm going to factor. So I have 2x squared. This is where, because I have a coefficient greater than 1, I have to split my middle term. 2x squared, and then I have minus 10, plus 10x minus 1x, because my two numbers I found were 10 and -1. And then I have minus 5 equals 0. Okay, so now I'm taking out my greatest common factor of 2x out of 10x and 2. Okay, remember from here when I'm factoring, I split it up into two smaller expressions. So I'm left with x plus 5. Okay, then I'm going to take my negative out. So I'm left with x plus 5 equals 0, right? Because when I distribute this, it becomes negative x minus 5, just like I have written here. So now this is in kind of an unsaid 1 right here. So I have x plus 5. I'm going to bring that out in front, and then I'm left with 2x minus 1. So now set these equal to 0. So I get x equals -5. And x equals 1/2. Okay, so what makes more sense, to have a negative value for the width of our border, or to have 1/2? Well, it definitely makes more sense to say our border is 1/2 feet wide, not -5 feet wide. So 1/2 feet wide is our border. Okay. All right, so that is it for the day, you guys. If you have time left in class, go ahead and just work on your homework. All right, bye guys.